Welcome to this lesson on fluid flow. Today, we'll explore two fundamental types of fluid motion, laminar flow and turbulent flow. Understanding the difference between smooth and chaotic fluid motion is essential in fluid mechanics and has applications in everything from blood circulation to airplane design. Fluid flow refers to the motion of liquids or gases through space or within confined systems like pipes. The behavior of this flow is determined by several key factors: the velocity at which the fluid moves, its viscosity or thickness, its density, and the geometry of the system it flows through. These factors work together to create different patterns of flow. Laminar flow is characterized by smooth, orderly movement. In laminar flow, the fluid moves in parallel layers with no mixing between them. Each layer glides smoothly past the adjacent layers. The fluid particles follow straight, predictable paths called streamlines. This type of flow typically occurs under specific conditions: when fluids move at low velocities, when they have high viscosity like honey or oil, or when they flow through small diameter pipes. Turbulent flow is the opposite of laminar flow. It's characterized by chaotic, irregular motion with constant mixing. In turbulent flow, you'll see eddies, swirls, and vortices forming throughout the fluid. The particles move in random, unpredictable patterns with cross-currents moving in different directions. This type of flow occurs when fluids move at high velocities, have low viscosity like water or air, or flow through large diameter pipes. So how do we predict whether a flow will be laminar or turbulent? This is where the Reynolds number comes in. The Reynolds number, abbreviated as RE, is a dimensionless number that helps us predict flow type. The formula is Reynolds number equals density times velocity times diameter divided by dynamic viscosity. This number compares the inertial forces, which tend to keep fluid moving, to the viscous forces, which resist motion and dampen turbulence. Let's break down each variable in the Reynolds number formula. Rho represents fluid density, measured in kilograms per cubic meter. V is the flow velocity in meters per second. D is the characteristic length, typically the pipe diameter, measured in meters. And mu is the dynamic viscosity, measured in Pascal seconds, which tells us how resistant the fluid is to flow. By calculating these values, we can determine what type of flow to expect. The Reynolds number gives us clear boundaries for flow types. When the Reynolds number is less than 2,300, the flow is laminar, meaning smooth and orderly. When the Reynolds number is between 2,300 and 4,000, we enter a transitional region where the flow is unstable and can switch between laminar and turbulent. When the Reynolds number exceeds 4,000, the flow becomes fully turbulent with chaotic, mixing behavior. Let's look at some real-world examples. Laminar flow occurs in blood flow through tiny capillaries, where the smooth flow is essential for proper circulation. You can also see it when honey pours slowly from a jar or oil moving through small tubes. On the other hand, turbulent flow is what you observe when water rushes from a faucet at high speed, air flowing around an airplane wing, or water moving rapidly through river rapids. Understanding these flow types helps engineers design better systems, from medical devices to aircraft.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.